we are starting the webinar on renewable energy for human security, and I am in a great company of some wonderful, good old friends and one younger friend also. And it's really my pleasure to have such great people here, because now there are actually three reasons that we called for this webinar. The first one is that the doomsday clock is at the moment pointing at 85 seconds to midnight, which is worse than last year, worse than any time in history. The worst nuclear crisis were only 2 minutes, but now we are at 85 seconds, less than a minute and a half, and every year it's getting worse. So now the question is, what can we do? We obviously need to do something. And the thing that we need to do is everywhere, and renewable energy is one of the fronts where we can do something. Why? Because if you look at this price of energy, from the last, 10, 20 years, even longer, these prices have determined the economic destiny of many nations, and also the economic crisis and the wars. So at the moment, you see, we have like a big war in Ukraine that just doesn't want to stop. And on one hand, we have like a nation that's trying to defend its borders. But on the other hand, we have another, we would call it, okay, I won't call it a country, but we have an attacker who depends on selling the energy. And this selling price of energy is just a little bit higher than the production price of energy. So if renewable energy could like decrease the price of energy by, let's say, maybe between 30 and 40%, then there is no more money for this war machine, which means that the biggest war in Europe could stop, and other wars are actually very similar. You have seen what is happening, the latest dynamic, and therefore we call this webinar, and we invited some really wonderful people. So as you can see here with me, there are panelists: Professor Neven Dujic from SDEVE Center, Professor Ugo Bardi from Ex-Com Club of Rome, Dina Dragia, who is also the president of the Youth Leadership Network and co-founder of Unwasted. We'll also invite other people, Dr. Bozesan later, and everyone. I mean, everyone will be invited. At the beginning, we are just going to go for a short introductory presentation, because one of the outcomes is also to try to connect our organizations better. So to figure out where are the synergies, what can we do better. And there is also one more lady, Professor Phoebe Kondori. She is just in a plane. She was delayed slightly, so she will join us during the time as we go. And for the introduction, after this introduction, I would just like to ask our first guest, my very dear good friend, Neven, Professor Neven Dujic. Actually, I met him first at the SDEVES conference. It was, I don't know, quarter of a century ago almost. And that SDEVES conference was actually a great idea, which started with some WAAS fellows. Ivo Schlaus was among the initiators, our honorary president, and then Robert Blins, Naim Afghan. And then it was like a small gathering. The first one was really small, but then Neven recognized the potential. And he formed like a SDEVES Center and did it systematically. And now the SDEVES conferences are visited by hundreds of people. It's 400, 500, 600 scientists that join every year and exchange their news on sustainable development. So I would really appreciate, Neven, if you're so kind to share your introduction a little bit on SDEVES Center, and maybe some ideas on how we can contribute to human security with renewable energy. So Neven Dujic, president of the SDEVES Center, vice president of the Croatian Engineering Academy, and many other functions. I won't list them, so because we are looking forward to your presentation.
Thank you, Aleksander, to this very nice introduction. Let me go through a little bit connection between SDEVES and renewables. Renewables are now, or wind and solar are now, the cheapest sources of electricity. And we can see that most of new capacity added on a global scale, now it's basically wind and solar. And in a way, when we started the conference, we understood the importance of sustainability, of new and renewable energy systems, from the beginning, but this problem came out relatively early as a big problem. Wind and solar are variable. So we have to think how to best integrate them into power system. So already in 2009 at the 5th conference in Dubrovnik, we understood that energy planning has to connect power to heat, transport, water, hydrogen. So kind of multi-energy system integration. And at 9th conference 2014, we already started to talk about smart energy system and integration of power, heat, transport, and water. We were much before time. We are now hearing politicians talking about it. But if we compare it to IPCC in the first 5 assessment reports, they really didn't know what to do with renewables. So they were depending heavily on carbon capture and storage and nuclear, which did not happen. So we were right and they were wrong. Only assessment report 6 recognizes electrification of heating, transport, and industry as a way to go, but still does not fully solve high variable renewable penetration systems. So what happens? If you have a lot of wind and solar in your mix, that means your base load is going to be pushed out. You can sell it to somewhere else, but they will also have very high penetration of wind and solar, probably at the same time. So this is not going to be that good. You could store it, but it's very expensive to store coal electricity. So the best thing is not to produce it, which means there is the end for baseload. But how do we solve renewable variability or so-called intermittency problem? Well, one way is to improve the integration of power systems to build more interconnectors. If you look at the pale blue line, you see that variability of wind is very high on a small country level. But the black line is Europe as a continent. And there you can see that wind is not that variable at all. So if you build about twice as much grid, that is the cheapest solution to integrate more wind. And then we can see on a continental level that wind is actually kind of baseload with excess. So we have wind always at every single hour during last 7 years. But we have to find ways how to utilize the excess of wind above the red line. We need thermal power plants to be flexible, and we can see that hard coal thermal power plants in Germany are now very flexible. They're basically turning off and on twice a day and producing less and less electricity. Nuclear power plants are also becoming flexible, and this is absolutely killing the finances of nuclear power plants, the new ones especially, because they are going to be working much less hours, because they will have to balance wind and solar. Such variability of wind and solar is bringing also some advantages, and that's a low price of electricity in some hours. When electricity is under 20 euros per megawatt hour, that means on thermal basis, it's cheaper than biomass. And we can see that it's often the red line is under this horizontal red line, meaning it's cheaper than biomass on thermal basis. And it's becoming more and more negative price. In Europe, there are many countries which has several % per year of hours which are negative prices. In South Australia and Victoria, it's already 24% of time it's negative prices. What can we do with free electricity, or even they pay us to use this electricity? Well, we can convert it to heat, and this is what Danish are doing. When the price is high, they use cogeneration plants to produce electricity and heat. When the price of electricity is low, they turn electricity into heat and they store it. So we are more and more going to be heating on this cheap wind and solar electricity. Also, electric cars are coming, and we can charge cars only when there is excess of wind and solar. Remember that cars are parked 90% of time, and we need to charge them only maybe once a week. In most of cases when we're just driving in urban circumstances. We can see that electric cars are exploding even in developing countries. Nepal, for example, had more than 70% of market last 2 years were electric cars. Ethiopia banned imports of internal combustion engines, and it's practically now 100% electric car market in 25. So things are changing very quickly. And one thing that we discovered with all these flexibility measures, we can actually increase the integration of variable renewables. So with wind and solar, with the classical system, can only go up to maybe 40% of share. And after that, it becomes too much of curtailment and difficult to integrate. But if we add all these measures of increasing flexibility, we can go all the way up to 70, 80%. This is a very unflexible Bulgarian system. So in most of systems with hydro, we can go easily up to 100%. So we are moving towards a power system which will be based on overbuilding of wind and solar. Overbuilding means they will most of the time cover the legacy electricity demand, plus covering transport, electrified transport and electrified heating, which are very storable type of demands. And probably around 40% of energy will be still used for production of hydrogen, for fuels and feedstocks in industry. Thanks to this research, partially coming from SDEVES, but also coming from other research groups, IPCC in Assessment Report 7 has finally understood the importance of integration, and they have added the chapter 14 to Working Group 3, and I'm one of the co-chairs of that. And SDEVES conference series has helped this process with creating scientific evidence. And this is the important part, why we need conferences in order to create scientific evidence. And these are the members of the SDEVES conference, which are now authors, which will try to flesh out Assessment Report 7. Thank you.
Many thanks, dear Neven, for this wonderful presentation. So in principle, we have questions after all the first round presenters present, but I have like 2 short questions, if I may. This what you presented is actually very much in line with the goal of this, the contribution to human security. And the question here is, you show that wind and solar are much cheaper than other sources of energy. So if, like most countries, implement these wind solar energy systems, by how much do you think the price of energy would drop, and how fast can this be implemented? So it's actually one question.
Well, the price does depend only in hours in which solar and wind are the marginal electricity generating technologies.
Yes.
So now it happens in a few hundred hours, but we need to build much more wind and solar to get this low price in what we expect will be around 4,000 hours per year. Price will be more or less zero. But in some hours, it will be quite expensive, depend on what is the marginal technology. So if marginal technology are batteries, then it will not be that expensive. But the marginal technology is gas. In those hours, it will
Yes.
be expensive because gas is expensive. But more and more renewables doesn't mean that the marginal cost in most expensive hours falls down, because that only depends on gas price.
Yes.
But it depends how much is the average cost of electricity.
Absolutely. I mean, the question was because if you like convert most of the mobility to electricity from sun, from wind and solar, then you don't really need that much gas, which means that the gas price would also have to go down. And the question is, how many years do you think would be like a reasonable estimate until this transition that most countries go to mainly solar wind energy?
Well,
How many
what
years?
we are expecting that by 2050 the transition will be more or less finished in developed countries, and developing countries will have different pathways. China and India are more or less planning for 2060. Some of the poor countries will do it much faster because it's now cheaper,
Yes.
and they don't have lock-ins. So if we look at the locked-in countries with lot of fossil fuel investment, they will probably be laggards, especially oil-producing countries. But I would say more or less most of the world will be transited by 2060.
2060. Many thanks, Nevin, also for this wonderful explanation. And also for this, this is actually a great starting point for our next presenter, because you mentioned there are differences between countries. And our next presenter is Professor Ugo Bardi, who is member of ExCom of Club of Rome and many other organizations. And what he did recently was a very nice book on population dynamics. And this population actually tells us what is happening in the world, where can we find young people motivated to work on the areas that we need, and where there is lack of them, and what to do to get enough young people really to join the efforts and to make this world a better place. So I'm really looking forward to a presentation of my dear friend Ugo. Ugo, the floor is yours.
Thank you very much. And let me add to what you said that I'm also a member of the World Academy of Arts and Science. Well, okay. So today I prepared a short presentation which doesn't deal directly with renewable energy, but it ends with a good reason for having renewable energy. We need it. We absolutely need it, and we desperately need it. And it is based on this book of mine that I can show to you here, and just came out 1 week ago. So it is a global study of the trends of population based on mainly on the models, on the dynamic models that the Club of Rome developed already more than 50 years ago and are still being used, and providing approximate descriptions of what we are facing, what's happening. Basically, models do not predict anything. They just tell us what could happen if, and that's the fundamental point. So the question is, now we are going to see most likely a decline of population within the next few decades, which means that we're going to go slow down, which is already happening. Population growth worldwide is slowing down, slowing down. Some projections say it will keep going on up until the end of the century, but the dynamic models say, well, this is not so evident because we have several factors conspiring against the continued growth. So some models predict, in quotes, because we cannot really predict anything, but some models say, well, if you are not careful, you could start declining in a few years, not decades. And that's a very fundamental point. So a question that I prepared for this talk, okay, this may be bad for some reason, good for others. And one point is, okay, we have this enormous, gigantic, fantastic, humongous problem, which we call global warming or climate change. Now, if population goes down a little bit, we don't want the extinction of humankind, please. But if it starts going down, is it going to help? in a certain sense, yes, it is, but with a certain attention. And I'll show you that it is not sufficient. It is a result that was already obtained in 1972 by the group of people who prepared the first report to the Club of Rome, The Limits to Growth. They said, well, could population stabilization solve all problems? And the result was no. Now let me show you some data. Let me share dynamics, the great inversions. I was telling you about this first work by the Club of Rome, The Limits to Growth, in 1972, and just to show you, I don't know if you're seeing the arrow on your screen, but the population is this brown line. According to these first calculations, would start going down to around 2050, which was already a revolutionary result, because it was the result not just of demographic trends. The standard demographic way of dealing with population is purely statistic. You build the population curve on the trends of the previous population. So what's happening now? People are having children now because they were born maybe 20 years ago. So you can calculate the growth of population over time, but this model is much more sophisticated because it contains data and effects and resources on climate, which we can say it is proportional of these parameters called pollution. Pollution here is a minor factor, but it is already important. And we have the food per capita, the industrial production, and other factors which all affect population. This was the first attempt for having been done 54 years ago. It is already something impressive, because so far we have been following these curves reasonably close. Now, we are not worshipping an old calculation. This is being redone in various ways. So let me show you this very recent result of last week. My colleague and friend Bennett Worm sent it to me. He said, Ugo, look, this is the latest update of the Limits to Growth. Now, it's very recent. And you see the population now, the peak of the population has shifted back to about 2030 or 2028 or something like that. So it might be very close. And we are going to see. Okay, I'm not making prophecies. I'm not a prophet, and I don't have crystal balls or things like that. It's a possibility. As I said, models tell us, okay, that's what could happen. What if? But the interesting part is that now the pollution curve, which is proportional to global warming, has been also recalibrated, re-examined, and even though in this model, population starts going down in a few years and goes down relatively rapidly. By 2100, you can calculate that, wow, you see these numbers here? Ouch. I'm not going to comment on that, but it could be 10 degrees of temperature increase. Okay, before you run away screaming, etc., you remember that these models all models are limited. There is no technology here. There is no renewable energy in this model. It supposes that we do everything we have, fossil fuels and usual trends, agricultural things, and the cost of resources, metals, and everything. And so it is rather pessimistic, but we have to be careful. This is an answer to the question, what is it going to happen if nothing changes? We keep going the same way, using the same technology, the same techniques, the same sources of energy. Just to let you know, we can't think of changing. And this is the most recent report to the Club of Rome just a few years ago, Earth for All, that you probably heard about. And here we're starting to examine what happens if we start changing something, including renewable energy, including things, including controlling a little the path of the industrial civilization. Essentially, the main point here is that we work for a better equity of people. People are encouraged to do well, to save energy, to invest in renewable energy, to use new technology. And so in this case, you see this on the right, lower right, you see that we can reduce the GHG, greenhouse gases emissions, so we can do something much better. This is very different than a model in which we do nothing happens. The greenhouse gases keep going up because we do nothing, then they will accumulate in the atmosphere. Even if the rate of emission were to go down, they keep growing. Instead, here we are doing something to reduce gradually, not killing anyone, by gosh, but we do something. So this is very general, as you see. As you see, we have to fight this behavior that always says the same result, that if we don't do anything, resources go down, population starts going down a little later after the economic capital starts going down, but pollution keeps growing, and that's a huge problem. If we don't do something now, we will find ourselves in a deep economic crisis without being able to invest enough to fight pollution, which in this case stands for global warming. It's a disaster. And because we invested everything we had left in the military build-up, which is what we are doing now, and nothing is left for fighting pollution. And it is possible. That's the only thing, the last thing I want to show you. It's a little bit of an old work that we did 8 years ago, but it shows that the same models tell you that you can, if you invest enough, and it is possible to invest enough, because this is a calculation based not on financial data. Financial can be changed in various tricky ways, but the energy is a parameter that you cannot play with. You cannot trick energy conservation, and not even entropy. And so it shows you that if we are willing to invest sufficiently large amount of energy into building a renewable infrastructure, then by 2040 we could go through what is called the energy transition and have a world based mainly on renewable energy, which would be a very nice world of the kind that Professor Duik showed to us in the previous talk. And that's all what I wanted to tell you. The main point is that, population decline alone is not sufficient to contrast global warming. We need proactive measures, renewable energy, ecosystem restoration, and most likely also CO2 capture, because otherwise I don't think we can make it. And you can find more data on this point of my new book. Sorry if I act like a salesman, but I put a lot of work in this book, so I'm very, very possessive about it. And also in my blogs that you see there. I said that I don't have a crystal ball, but sometimes I do use one. And thank you very much.
Many thanks, Ugo, my friend, for this wonderful presentation, for a beautiful book. I have actually reviewed it before publication, so I can guarantee that it's really excellent. And also for this wonderful presentation. You know, this last slide, I mean the second to last slide of yours, it's actually interesting because although it shows that we need a few decades for this transition, it also shows that in a very short time, a few years, maybe 2, 3, 4 years, you can actually drop the amount of fossil fuels used by so much that its price could be reduced significantly. And that's actually what we are aiming for, so that the fossil fuel price goes down and that the people who are using fossil fuels for not good purposes are not really capable of doing it no more. And maybe just a short question regarding this population dynamics. So as I said in the beginning, we are actually wondering where can we get, there will be a decade of transition. So we are going to need a lot of motivated young people to work hard in science, in technology for this transition. Where do we get them?
I think from China.
Okay. China population is also going down.
It is going down, but they're still creating more than 3 times more engineers that we are doing in Europe.
True, very true.
That's something, and because they are investing a lot of money into human capital, and it works.
Very
My
important.
gosh, it works. Yeah,
exactly. It's very, very important. Very important. So now, actually, I see that also Professor Phoebe joined us. Now we are actually at the third presentation. So maybe we go first with Dina and then we return to Phoebe, if that's okay. Because now this was actually just a great starting point for Dina. You know, Ugo was explaining how to get young, motivated people, and our wonderful Dina, who is also associate member, associate fellow, is also the president of the Youth Leadership Network and also a co-founder of the Unwasted, and she has some wonderful ideas in this regard, and I'm really looking forward to hearing them.
Yes, thank you very much for inviting me today to contribute as a young leader and also the associate fellow of the Academy. Today, I would also like to, as we are all aware, energy is one of the main pillars of human security because it really brings the national security, economic stability, and independence, which is much needed in such uncertain times. So I'm very happy to speak on this topic, but also as our colleague Neven mentioned, scientific conferences are really important because we are not lacking solutions, as we could see. We have the solutions, but sometimes it is really hard to engage the wider public. It is really hard sometimes to engage younger generation or also to engage sectors to collaborate around certain solutions. So that's why today I will focus on the Unwasted Forum, a networking creative platform that last year I personally co-founded with one of the other colleagues from Croatia and also Donato, our vice president. So today I would like to show you how we structured this creative networking platform that really showed many solutions from sustainable tourism to fashion design, also clean energy. And we really experienced action. And the general public was involved, the young people were involved. So that's why today I decided to speak about some of the solutions, how we could present the solutions we have. I would share the screen now. Yes, this is the Unwasted Forum that we co-founded under the patronage of the World Academy of Arts and Science and United Nations Trust Fund for Human Security. Also, Club of Rome was a supporter and Ugo was there, same with Aleksander. And big thanks for supporting us. As I said, the idea behind the Unwasted was to create a creative strategic networking platform that will show all of the solutions that might be beneficial for sustainable development goals and human security goals. However, we tried to really make it engaging and different so that the general public and, as we said, young generation can also be involved, because sometimes it's really hard to translate the solutions that we are providing. And we want to include not only the scientific, but also the public and private sector to collaborate and also to have the wider public to engage with the topics. So at the Unwasted, we showed that when the science, diplomacy, and the other sectors collaborate in a creative way, also through art, fashion, and design, it really can make an impactful change. So under this forum, that was not only scientific conference, we also had the fashion shows, we also had the practical demonstration where we were sailing with the boat on the Adriatic Sea, removing the fishing nets, and then showed the fashion show recycled fishing nets. So there was a lot of engaging solutions. And also for this 3-day event, the individuals from sectors that were part of the event really had the time to connect and to really start working together. Now I will show you the video just to get the idea how that looked all together. But later then I will speak how we presented the clean energy solutions in a creative way and how we really experienced some action steps even from the government.
Unwasted Forum, where sustainability and innovation meet action, a global platform for cross-sector collaboration. Policymakers, entrepreneurs, designers, scientists, and changemakers joined forces to implement real solutions. From groundbreaking projects to unexpected partnerships, every voice contributed to a shared goal: sustainability through collaboration and action. Unwasted 2025 showcased a powerful lineup of breakthrough solutions, from 75 tons of discarded fishing nets transformed into cutting-edge high fashion, to compressed air engines offering a cleaner path for transportation. Innovation took center stage. Biotech leaders like Marinex presented atmospheric protection solutions, while sustainable tourism models paved the way for a greener global travel industry. Nuclear energy was reframed as part of the clean energy puzzle.
It's also a symbol of how we can turn problems into possibilities and waste into worth, which brings together fashion, marine conservation, and community engagement.
So I have never been to a fashion show plus nuclear energy conference. Has anybody in this room?
It's about sharing, it's about increasing the diversity of ideas. This diversity of ideas is actually the key to our success.
Recycled textiles made their statement on the Green Fashion Week runway. From automotive innovation to net zero technologies for everyday living and bold ESG strategies from both public and private sectors, the ideas shared were ambitious, actionable, and aligned with a sustainable future. All backed by science, supported by innovation, powered by policy, driven by business. Together at Unwasted, we reimagined solutions. We rethought waste and environmental protection. We renewed our energy systems to accelerate the green transition. We reinvented fashion, redefined leadership, and committed to restoring our planet. Unwasted 2025 wasn't just a forum, it was a catalyst for real change. Together, we shape the green future.
So as you could see from the video, we really engage different sectors in a creative way, and that lead also to actions around the clean energy. Our focus this year was on nuclear energy, because we had the partnership with the Charles Oppenheimer, which is the grandson of the Robert Oppenheimer. And we knew that if we have this strategic partnership and we bring it to the region, that the also general public would be involved, and that really happened. So when we started this support around our forum, around the nuclear energy solutions, and we identified the leading scientists in our region connected with the foreign partners like Charles Oppenheimer Dialogue or International Atomic Energy Association, then we had really an enormous support also from the government and wider public, which now showed the really great results after the 30 years. Some of the scientists were not even carefully listened from some of the government officials. Now we experienced many collaboration, because first after we identified the scientists and the possibilities of our region, and also include the foreign partners, and also make it really engaging and powerful event, then we really connected government directly to the science, which when the media started to be really engaging around the Charles Oppenheimer partnership with the forum, of course, probably it happened also because of the movie, which also represents how it is important to kind of follow the trends that are happening if we are trying to translate the message to the general public. And also the government even independently contacted us and wanted to be part, which really kind of make an impact into the region, because it was the first ever roundtable with the scientists that were working on the potential nuclear plants 40 years ago. And first, when we started planning the agenda, they were kind of skeptical that the government will directly support them, because they say that they tried really to explain the potential of the region 30 years. But what happened is that when they gathered together and really have this intimate talk, the collaboration happened naturally. And that's why, as our colleague Neven also said, not only scientific conference, but the platforms where we can all connect and collaborate really matter, because it is sometimes easier to understand each other if we have such an intimate dialogues around the solution. As you here on the photos, you can see the scientists from Croatia and Slovenia, also the government representatives from both countries, and also Charles Oppenheimer and the representative from the Atomic Energy Agency. And as you could see, the key outcomes, 6 months after the forum, even our ministries are directly working with the scientists now. And as you could see now in the news, the Croatian government has sent a draft law on the development of the nuclear energy to the country's parliament. So we are really experiencing a drastic shift from what happened prior to the Unwasted and post-Unwasted, which is just today one of the examples how it can really lead to a change if we gather and connect right individuals at the right place in a creative way. And also if we engage public, because what I've could also notice from younger generations that there is not usually interested in some of the solutions that we might provide. I could experience that they were really interested in what's happening because it was presented to them in a way that it was engaging for them. Also here, if you could see, if you Google, you will see that the Croatia prior to the Unwasted didn't consider independent nuclear plants or solutions. Now Croatia really is going into that direction because here the science is key. I think that the government finally start working with the regional scientists that could really help to kind of identify the old locations or also identify the solutions on that topic. And I took this as an example. 9 months ago, this is Duško Čorak. He is one of the leading scientists around nuclear energy, and he has the private company Inetec. And first, when we contacted him to start working around the Unwasted Forum, he was really keen to support because he wanted to share the solutions he was working on 40 years ago and he's still working on, but he was really skeptical how government will react. And then now you can see that, 2 weeks ago, you see the minister visiting Inetec. Here, 9 months before, he was stating that he is coming to Unwasted Forum, and he was stating that he is almost working 35 years with the Inetec, and now you can see that 2 weeks ago, the minister personally visited the Inetec company. So we are really proud of this outcome because we think that it is the right way that government directly supports science, first and foremost, because science brings the solutions that are meaningful. And nowadays, if government officials are not the experts, we truly believe that we should connect those two sectors, that they should take the opinion from the science directly. And this happened regarding the nuclear energy and also other solutions. But I took nuclear energy as an example because it's similar to renewables. So it was okay. And as you could see, Unwasted was formed in a way to really bring many sectors that is engaging, and that's something that I would like to also put an emphasis on, that if together we can bring and create the networking platforms, I think we can also connect on a different level, individually and professionally, and then we could have the results, maybe without a long bureaucratic delays, because when you really are at the same place with the right people and you hear all of these solutions in the right way, and also if you engage young people and engage the general public, then you have a podium to really present the ideas. And that is the idea behind the Unwasted. What is interesting this year is that we were recognized by the Formula One side event, which is the electronic E1. That is the name of the Formula One side event. It is the E1 event for the electric boats. We are connecting our partnership now because they also want to build up upon marine protection, blue economy, sustainability, and they also had the summit similar to Unwasted. But now they want to partner up, and this year the edition of Unwasted will be in partnership with the E1. For us, that is great because alongside fashion, art, and design, we are also including sports as the medium to translate such topics as clean energy, or blue economy. So we are kind of proud also on this partnership because we think it will bring enormous visibility to also what the Academy does as well, because it's the global event. And also we are really proud to see that sports is also included in the sustainability solutions, which we think and we experienced that it was good for the actionable steps on the solutions we are providing. And thank you. This is from me.
Congratulations, dear Dina, not only for the wonderful presentation, but also for the great success of the Unwasted Forum. So now if you just go along these lines, after all this success that you had, now you're also planning, I mean, I was there, I mean, such an incredible close cooperation between fashion and science. I never saw this before. And now you're even added sport to that picture, which means there will be cooperation between science and fashion and sport. And we noticed that you're also doing this electric boats. So is this also going to be centered around renewable energy?
They have many topics. They want us to organize unwasted dialogues, VIP dialogues, and we could here, of course, have the dialogue around renewable energy because it is up to us. And of course, since we are collaborating with the Academy, there is a way that we can form the conversation in that way. They are mostly focusing on blue economy, of course, because it's the electric boat racing. However, they were really supportive. They are really happy also to include fashion because they understand it is very important to engage also the general public.
Wonderful. Thank you, dear Dina. It's actually a great opportunity. You see, after this success from Unwasted from last year, I was there. It was really wonderful. Now, this year, this could have a similar effect on renewable energy in Croatia so that everybody will want it and it will expand and it will grow just like it has to. And thank you again.
Thank you.
And now, as we are moving along, you see, our next guest is Professor Phoebe Kondouri, who is professor from Athens, also a fellow and a member of Board of Trustees of the World Academy. She is also the director in Athens of Euphoria and many other organizations. I will not list it. I would just like to add before you start that before the presentation that you missed, Neven from Zdeva Center, Professor Neven Dujic, our fellow, had a presentation on how fast we can transition to this renewable energy, the wind and solar, 100% wind and solar energy. The estimate was about 24 years in the developed countries and maybe 10 more years in other countries. And because, Phoebe, I know you're working a lot with United Nations and with these estimates on how to reduce the greenhouse gas emissions, and the renewable energy is actually the ideal way to go. So we would really like to hear your perspective on this and how we can contribute also to human security this way.
Yes, thank you very much, Aleksander. I'm really happy to be here. Yes, so I've been working on energy transitions, but also the whole systemic transition from where we are today to where we want to be. So for 30 years, I've been working on innovative systems transformation for the sustainable interaction between nature, economy, and society. And although I am an economist, a mathematical economist and statisticians, I always work in the interface between different disciplines. So I'm a really interdisciplinary creature as a scientist. And currently my affiliation is shared between the School of Economics at the Athens University of Economics and at the Department of Earth Sciences of the University of Cambridge. I'm a proud fellow and trustee of the World Academy of Art and Science, and I think that what you are doing today, but what we are doing over the years is valuable for the scientific community, for the interaction of the scientific community with all other significant stakeholders, politicians, policymakers, the youth and the civil society, technology, the multilateral world, and also the finance world, the world that finances all these transformation pathways that we want to build. So I always start my presentations with this almost permanent multi-crisis in the environmental system, in the social system, in the economic system. We know that we have very low growth rates, inflationary pressures, inability to integrate the fast pace of technological advancement into productivity. We have social issues, increasing inequality between the global south and the global north, between different income groups in the same countries, population crisis, food insecurity, energy insecurity, water insecurity. And we also have our environmental crisis, the climate crisis, the ecosystem collapse. All of this is creating a lot of pressures, and it seems that the multilateral system cannot handle these pressures. We have geopolitical pressures as well, and you've all been hearing what is happening with the leading countries in the world, especially big news today having to do with US tariffs, with US and Iran. So it's a very difficult multi-crisis, and it's almost getting a shape of permanency, which is really worrying. And what I argue is that our inability to work in an integrated way and break silos between the natural systems, the social systems, and the economic systems is what is making us unable to escape this multi-crisis. And I'm going to argue in this presentation, which will be mostly focused on energy, but I cannot speak only about one sector, because this is against what I believe is the solution. The solution is in the integration between the different sectors of the economy and between the four main layers of our development: nature, infrastructure, economy, society. And this is exactly what we signed in 2015 in New York, UN Agenda 2030. We signed an integrated, interdisciplinary to apply system that will bring the biosphere with 4 different sustainable goals representing it, with the society represented by 8 sustainable goals, with the economy represented by 4 sustainable goals, and then the most important goal of all, SDG 17, which is about the collaboration in order to meet the goals. And what I am always arguing, and this is what my work is doing, is that we need to break silos. We need to break the silos, which basically means we need to see the different sectors of the economy, the energy sector, the food sector, the water sector, the forestry sector, what we call in one word land use sector, together with marine use sector, together with transport sector, together with innovation sector, as integrated and embedded in a socio-economic system that will then talk and interface with nature and society in order to design the systems transformation pathways that we need in order to escape the multi-crisis. Working in the silos of the economic sectors, in the silos of the system, nature, economy, society, is not going to get us anywhere. It will continue building on fragmented solutions that are not working, and they cannot work because they are not correct. So we need to break silos. We need to build systems transformation pathways. We need to be science-based, and this is a responsibility that comes from us, the scientists. We need to be stakeholder co-design, and this is bilateral responsibility between the scientists and all other stakeholders, and I've mentioned them before, and we need to allow for clever blended finance to support the transformation pathways we co-design with all the stakeholders, but which are based on science. So the real constraint in our permanent multi-crisis is not about money, it's about translation. We need to translate public goals to investable projects, long-term needs to funded, compatible assets, and risk that exists to risk that is priced and allocated. And this is exactly what my work at the UN is trying to do. I'm currently the chief scientist for the Global Sustainable Report of the United Nations. This is a report that is written by 15 scientists, independent group of scientists assigned directly by the General Secretary of the UN. So what state are we now? Our state is that we have a brilliant comprehensive framework for transformation towards sustainable development. It's a brilliant framework because it's science-based, it's integrated, it's really what we need, 169 targets within the 17 goals, and a huge ability to quantify and measure exactly the performance of each and every scale that we have. Then we also know that we have achieved about 20% of implementation. This is not spectacular, but it's a big thing because the 17 goals, the 169 target are a difficult, challenging scientific structure that needed to be transposed into policy frameworks of the different regions and countries of the world and then start being implemented. So 20% is not spectacular. It's definitely not enough to fully implement the goals by 2030, but it's a very good start of implementing a very challenging and much needed framework. So now I believe that our key challenge is that we need a robust structure that is explicitly tasked with driving their implementation at scale. And what I always worked on and I believe in is that we need an operational global commons capable of aligning global efforts, creating accountability and ensuring effective coordination and delivering results on the ground. And this is exactly what I'm going to show, the global commons for SDG implementation in a three-step approach as my team and I have designed it. So this is going to go into the Global Sustainable Development Report of the United Nations, which is the flagship scientific assessment of global sustainable development and a key scientific input to the UN deliberations, to the UN high-level political forum on sustainable development. And our goal in this report is threefold: evidence-based policy guidance for integrated action, accountability that accelerates progress and is missing now, and laying the foundations for sustained action beyond the 2030. The first step for our global commons is continuous measurement, monitoring, and assessment with regards to the SDGs implementation. You need to know where you are in order to start building your pathways to reach your goals. And we know that there are, and we have co-developed many of them, extensive frameworks of matrices that allow you detailed quantification of where you stand against the implementation of the goals. Once you know where you are, and you have also committed to full implementation of the goals, which has been transposed into a policy framework. So you have in each and every country laws and regulations for the achievement of the goals that may come as in Europe in the form of the European Green Deal, 150 law of regulations, but at the end of the day, you do know where you need to go and by when. Then your goal is to design these pathways for SDG and national commitment implementation, uses system science modeling, and this is what we have developed, an extended mathematical system modeling that allows you to detail over time and across pace the changes that each and every country needs to implement between nature, infrastructure, economy, and society across all the sectors of the economy in order to achieve the goals. And while you're designing the pathways of implementation, which derive from this mathematical modeling, you always need to bring in the stakeholders, validate your parameters, validate the solutions you are looking into, and get the stakeholders become shareholders in your design. And finally, when you have agreed co-design and science-based pathway, you really need to bring in the who is going to finance these pathways. And you need to identify the investment portfolios and the financing transition policies between blended finance. We know that most money across the world is private, is not public. So although public money is very much needed, mostly for commons infrastructure, very important for the network of energy, it is also crucial to get the private money and be able to accumulate the funds that are needed for the transformations. And as I said in the first step, we have a big array of matrices, both for public elements of the SDGs, for the company transposition of the SDGs, the transposition of SDGs in the stock market. We have developed an extended framework of metrics. So we really know where we are against the goal for different scales, all different scales that one can think on. And then we also know where we want to go. Like I said before, for example, is Europe. We have transposed the UN Agenda 2030 into the European Green Deal. Although we don't explicitly say it, this is what happens, and we have relevant transpositions in other regions of the world. And then we design the pathways. To make sure that this pathways design is a global good, we need an open access infrastructure with data infrastructure that is AI ready and AI based, collecting all the data that you need for your modeling, geospatial data, socioeconomic data, real-time data. And then you need to pull together the models that are going to feed all this data in. First, the planetary boundaries. These are your optimization constraints. And then a snapshot of the economy in a beyond GDP economic model. Beyond GDP means that you are taking into account not just produced capital, but also natural capital and human capital and cultural capital. And then you start optimizing the energy model of your economy, the transport model, the water model, the land use model, including agroforestry, the marine use model. You can also include tourism, innovation sector, as many sectors that are very important and crucial for a country. And then you integrate, softly integrate the optimization solutions for these different models, and you embed them in the second calibration of the beyond GDP economic model that will tell you exactly what will be the effect of the suggested optimized changes in each sector of the economy, on each sector of the economy, on trade, and in general, on social welfare. And once you have these pathways, like I said, it is a continuous iteration process from the first moment you start thinking about the pathways, the first parameter of the first model to the final one, you always engage the stakeholders and you iterate the process continuously with the stakeholders. So at the end of the day, you have a continuous flow of SDG measurement, monitoring, and assessment, policy and governance transformations, technology transformations, capacity building. Is this crucial? Because as you change the technologies that you are using, the governance that you are using, you really need to invest in capacity building. It's quite worrisome how backward, how not up to pace is our capacity building and educational systems to the needs of the transformation pathways that we derive. And the last, of course, always question is how do I bring in together fiscal and financial capacity in order to finance the pathways. And financing the pathways and identifying the investment portfolio is also a very detailed process, starting from investment baseline, addressing strategic financing barriers, identifying pathways of investments and needs, developing and building investment plans and project pipelines, and then identifying bankable investments, monitoring, reporting, learning, and reflecting. And as I said, capacity building is crucial. We've done a study that identified that 85% of the jobs and skills that are needed to implement the European Green Deal in Europe is not yet in the European labor market. So this shows how much capacity needs to be investigated and investment. Now, let me use the last 3 minutes to just introduce some climate neutrality pathways that we are deriving. Who is we? IFORIA, the Alliance of Excellence for Research and Innovation on Sustainability, a big team of researchers, a big institution that I founded and lead. And it's focusing exactly on transition pathways to get the interaction between nature, society, and economy in such a rotation in order to get us to full sustainability. So here, like I said before, this is the actual implementation, the modeling implementation of the process, that the 3-step process that I showed you before. And what is important is that we integrate the energy models, the food models, the biofuel models, the marine, the water model, the land use model. We softly integrate them and embedded them in general equilibrium modeling, always having stakeholder co-design in order to get our results. For example, let me give you an example for the 35 European countries, and I agree with what was said before, that in about 25 years, developed countries like European countries can become climate neutral. Here we have 2 scenarios, both optimized for the 35 states in Europe, including 27 European, the Balkans, and the UK. We have the do-nothing scenario, which assumes continuation of current trends, and we have the national commitment scenarios, which assumes that the main climate neutrality policies are jointly implemented. And the climate neutrality policies that we focus on are the national energy and climate plans, are the common agriculture policy plans, and are the water framework directive, whatever manages into directives and law water in these countries, which is basically dictated in Europe by the Water Framework Directive into the river basin management plans. So we integrate the joint implementation of these policies because we believe that it is not enough to solve the energy policies. It is not enough to solve the food the common agriculture policies by itself. It is not enough to look at the water sector by itself. We have to look at them in an integrated mode. And when we integrate all these models, we find that Northern Europe retains industrial footprint despite lower volume. Mediterranean countries maintain strong transport and residential slices. We also show that early committing nations display smaller 2050 demand than later adopters. And with regards to greenhouse gas emissions by 2050, all countries' emissions shrink dramatically until the national energy and climate plans. Transport remains an emission source in Southern Europe, and eastern states like Bulgaria, Romania continue to show significant industrial emissions, reflecting slower fossil fuel phase out. This is the picture of Europe. With regards to energy consumption and greenhouse gas emissions per sector between 2025 and 2050. And you can show how much energy is consumed by each sector. And you can also see what is the energy supply, the energy sources, and again, the greenhouse gas emissions per fuel. And what is interesting to see is that by 2025, supply side emissions peak in Germany, Poland, and Italy, while oil refining also contributes heavily in Eastern Europe. And by 2050, supply side emissions drop sharply. Northern European nations benefit from abundant renewables, exhibiting minimal remaining emissions, and countries with substantial 2050 hydrogen shares like Sweden record almost zero supply side emissions. What is important to understand from these slides is this is what is going to happen if we implement our now agreed national commitments with regards to energy, and we also integrate in these solutions national commitments of the agriculture sector, national commitments of the water sector. And for some countries that have strong shipping, we also integrate national commitments for the shipping sector. And not only we can identify demand and supply and how they change every year, and how energy sources change every year, and how technology changes every year in order to meet this commitment, we can also design the efficient energy corridors and the efficient energy grid for the different energy sources that we have. All these works have been funded by my European Research Council project, for which I'm very grateful for. So let me also reiterate that in these energy solutions, we also integrate sustainable pathways for food, water, energy, and biodiversity. We integrate water calculations, we integrate biofuel calculations, we integrate land requirement for renewables calculations, and we even integrate in very vulnerable areas of Europe climate resilience interventions. So that we acknowledge the fact that we expect a high frequency of extreme weather events because climate change is here, and we intervene to reduce these effects and to reduce the after the extreme event destruction, so that the costs of recovery are minimized. So there is a lot of work in IFORIA, the Alliance of Excellence of Research and Innovation on IFORIA, my research center that is jointly hosted by the Athens University of Economics and Business, the Athens Research Center, which is a research center on information technology, AI, and machine learning, and the University of Cambridge. And in this work, and I need to acknowledge my co-workers, my researchers, more than 200 researchers working in more than 120 countries. In a few months, we will present the energy, water, food, biofuel, marine sector, transport sector, solution pathways for the whole of Asia as well. So we have advanced the modeling beyond Europe, and not only work on the science, but a lot with the stakeholders. And we also have a big involvement in the science policy multilateral interface, a lot of involvement in innovation acceleration. We accelerate about 350 startups every 5 years. And of course, we are grateful to all the academies and scientific associations that we are member on, and they represent a valuable platform for communicating our work. Thank you for your patience.
Many thanks, dear Phoebe, for this really comprehensive presentation of such a complex issue of this implementation of the SDG, which is very important. And I mean, I know there are hundreds of questions now, but maybe I'll start just with one. This will actually cost a lot. So we will need a lot of billions for that. So what is the estimate of the cost, and where do you think this money can come from?
The estimate of the cost, I don't want to give a number because it depends on the country, on the region. For the different solution pathways, we have the exact estimates of the cost, and we have also something else, and it's also another published paper. We showcase that through the integration between the different sectors and the optimization of the timing of implementation of the different technologies and solutions, we can have serious cost savings. Then the answer to so first, we can have a lot of cost savings compared to what it is claimed in the national energy and climate plans that they are gonna cost, if we do it in a more integrated way. The second big result and important result is that it is crucial to understand that, for example, for the most part, the grid, the network, has to be financed by public money, taxpayers' money. In countries that have fiscal space, through their fiscal space. In countries that don't have fiscal space, we need a good restructuring of global financial architecture in order to be allowed the flows of money. We need a restructuring in terms of who is allowed to borrow. It is completely not efficient to deprive countries that are weak from borrowing, because that creates a vicious circle of not being able to perform. And it also pays little attention to the fact that the growth rates that the countries that are not yet developed but are developing, the growth rates that they can achieve if somebody invests in them in long-run projects, mainly education, digitalization, electricity grid, and health, no developed country can achieve them. So it pays to invest in sustainable development in the global south. What is needed, however, to do that is to de-risk the projects. De-risking the projects means that you reduce the probability that the country will go into default, that you strengthen the institutions, that you help capacity building, create the labor force to be able to implement, that you reduce corruption. This will not just guarantee the implementation of the projects funded by fiscal space, either multilateral fiscal space that is multilateral borrowing, but will also attract private money. At the moment, we have 30 trillion of private funds sitting in savings every year, not being invested because the interesting opportunities are too risky. So we need to de-risk these projects, and the money is there. We have the money, we have the science, we have the technology and the money, but we need to risk the projects and implement it. Thank you.
Much obliged. So I know there are like hundreds of questions. I mean, I have hundreds of questions for each presenter, and the time is already kind of running late, and we need to be practical. So we are talking now about billions and hundreds of billions to redirect them into renewable energy and in the more sustainable project, but also we as members, as fellows of the Academy, and as members of organizations like I4EAS, WAAS, and others, Unwasted, we could actually collaborate better together. And now, for the end, I would really like to challenge all presenters in the second round, just in one sentence, if you can tell us what would be like a great way to move forward, what would be like the biggest contribution that we could do now as an academy together, and in one sentence, if I may, just first, my dear friend Neven Dujic.
Well, this is a good starting point, but I would have liked more discussion, open discussion, to see. We are closing to the end. We need more discussion about solutions,
absolutely,
and not only presentations. Thank you.
Absolutely, yes. And Ugo, my dear friend, can you in one sentence summarize what would be now a good next step?
Good question. you know, Aleksander, I am a big fan of renewable energy, and I am often accused to be a one solution person, which I am not. But I really think that that's the way we have to go, because without energy, we cannot do anything. And so we desperately, badly, completely, absolutely, incredibly need energy. And unfortunately, what's happening now is that our government, even in Italy, not just Mr. Trump, even in Italy, our government is actively sabotaging renewable energy. And that's a political question, which honestly, I don't know how to solve. What do you think?
But we have another panel member from the young generation. Dina, what do you think? How could we change the direction
Dina,
of
what
development?
Do you think?
Yes, it's very hard to change the world alone. And it's not only about the renewable energy or one pillar alone. I think as the Academy, we really have a lot of solutions for different sectors, and that we should see how we can engage together through joint projects. From my experience, I'm really grateful that Academy supported our forum, and I hope that we will continue to work together as the Academy on the other projects, the other sectors, and to see how we could implement all of these solutions for human security, because it is not mutually exclusive. It's really connected like the one organism. But I think it's very important to really engage also the wider public and the younger generation, as I showed in the presentation, because it's important that these solutions go outside the meeting rooms, outside the such agencies or in academies, but to really engage others to join the movement and monumentums. And I think that solutions we have, we just have to think on the strategy how to collaborate more actively together.
Wonderful, thank you. And our dear friend Phoebe probably has some ideas of how to better engage people.
Yeah, I really believe in transparency. Let us make all the data available, all the solution pathways that we have available. Let us be available truly to explain them in non-scientific terms, science-based results in non-scientific terms. And let's create accountability. Accountability means that I have a target. I am asked every year or every 6 months what I am doing in order to implement it and how much am I using the information that is available. So for me, open science and true open science, not just making available data and models and results, but going out there and explaining and talking to all the stakeholders, the youth, the old, the politicians, the policy makers, and make them aware, but also increase pressure for accountability through initiatives of stakeholder true engagement. Give them the message that this can be done. We have all the ingredients to do it. We have to get our resources together to really implement it, and it will be good for everybody, for the economy as well, for jobs, for profits, for everybody.
Many thanks, dear Phoebe, for this wonderful sentence. And now, I know we promised to finish in 1 hour and a half, but we have such great brain potential here. I'm opening a general discussion. So if anybody else from the audience has some great ideas of what we can do as an academy or as individuals that would really help to make this renewable transition speed up, now I open the floor. There have been so many great ideas already presented that it's probably difficult to add something. But for the end, I would really ask everybody, let us join in the project. You know, we are preparing at the moment some projects also together with the academy. There is like one Templeton project, which I hopefully will go through. And with Neven, we are preparing another Erasmus project. I know that at Alma Mater, they're preparing projects. Phoebe is preparing projects. I mean, there's lots of projects going on. On one hand, we speak about billions and hundreds of billions. On the other hand, we speak about little money so that we can do some more serious professional projects. And I would really like to challenge everybody. Let's join in this. Let's do this together. And let's move forward so that the academy will be stronger and that our projects will make a massive difference for the future generations to come. And thank you again for these wonderful presentations.